If a function is increasing or decreasing, then we can find its x-intercept and its y-intercept. An x-intercept is always the point where our linear function intersects the x-axis. That point will always have some x value, but the y value will always be 0. Similarly, when we look for a y-intercept, that'll be the point where our function crosses the y-axis. There will be some y-coordinate, but the x-coordinate for that point is always 0. What we want to notice in this pattern is that it's the opposite variable that's equal to 0. So for an x-intercept, y is equal to 0. For a y-intercept, x is equal to 0. And we just need to know to use that substitution in order to find intercepts for a given equation. That means that in example 7, when we have the function f of x is equal to 10x plus 1, and we want to find the x-intercept, we're going to set the opposite variable, so set y equal to 0. So we'll set this up as 0 is equal to 10x plus 1, and then we'll solve for x from there. To do that, we'll subtract 1 from both sides. And then in our last step, we'll divide by 10, giving us negative 1 over 10 is equal to x. Now we have our x value that we generated by setting y equal to 0, so our coordinate pair will be negative 1/10, 0. That's our x-intercept. And in order to find our y-intercept, we set the opposite variable, so we set x equal to 0. This will give us y is equal to 10 times 0 plus 1, or just y equals 1. One nice thing about function notation is that if a linear equation is written in function notation, it has to be solved for y, meaning our equation is in slope-intercept form. So the other thing we can do, we don't really have to do any work to identify the y-intercept. We can just look at that b value and know that that's our y-intercept. If that doesn't occur to you, though, you can always just substitute in 0 for the opposing variable. And then in this case, we would have the point 0, 1 as our y-intercept.